Hello, in this lecture we will find the area of the green triangle. In the drawing we have an equilateral triangle. Triangle ABC is an equilateral triangle, and inside the triangle ABC we have the green triangle, and we want to find out the value of the area of the green triangle. We actually know that angle FDE of the green triangle is a right angle, it equals to 90 degrees, and we know that line segment BD equals to 4 units, line segment DC equals to 4 units, and line segment BD equals to 2 units. Again, line segment BD equals to 2 units, line segment DC equals to 4 units, and AF equals to BF. AF equals to BF, and we want to find out the area of the green triangle. First of all, in equilateral triangle, all the angles equals to 60 degrees, so we can write here that this angle is 60 degrees. Also, this angle is 60 degrees, and this angle is also 60 degrees. And in an equilateral triangle, all the sides of an equilateral triangle are equal to each other, so AB equals to BC equals to AC. So we can write that AB equals to BC that equals to AC. Okay, but we know that BC equals to BD plus DC. BD plus DC equals to BC. And BD equals to 2 units and DC equals to 4 units. So BC equals to 6 units. So actually we can write here that AB equals to BC equals to AC equals to 6 units. And we also know that AB equals to 6 units. And we also know that AF equals to BF. So if we will define AF as X, BF also will be defined as X. And actually we know that AB equals to AF plus BF. But AF is X and BF is also X. So actually AB equals to 2X. AB equals to 2X, but AB also equals to 6 units. Okay, so in total we got that 2 times X equals to 6 units. We can divide this equality by 2 and we'll get that X equals to 3 units. So actually, the size of BF is 3 units, and the size of AF is also 3 units. Okay? In the next step, we will implement the law of cosines in order to find out the value of FD. Actually, we will define the value of FD as A. FD equals to A, and we will define the value of DE as B. DE equals to B. And we will find out the value of A according to the law of cosines. What is the law of cosines? The law of cosines states that if we have triangle in any triangle, it applies to any triangle. Okay, in any triangle, if this side is A, this side is B, and this side of the triangle is C, and we also know that this angle equals to theta, then according to the law of cosines, C squared equals to A squared plus B squared minus 2 times AB cosinus theta. Okay, so according to the law of cosines, in this triangle, C squared equals to A squared plus B squared minus 2 times A times B times cosinus theta. Okay, so we actually can implement the law of cosines in our triangle, because we will focus on triangle BFD. We will implement the law of cosines in triangle BFD. Okay, so in triangle BFD, A squared will be equal to BF squared plus BD squared minus 2 times BF times BD cosinus 60 degrees. Okay, so we actually implemented the law of cosines in triangle BFD. In triangle BFD, A squared equals to BD squared plus BF squared minus 2 times BF times BD cosinus 60 degrees. Okay, so that is the implementation of the law of cosines on triangle BFD. Okay, so we can write that A squared equals to BF squared. BF equals to 3, so 3 squared is 9 plus BD squared. BD equals to 2, so 2 squared is 4 plus 2 times minus 2 times BD is 2 and BF is 3. Cosinus 60 degrees is actually equals to 1/2. Okay, so in total we got that a squared equals to 9 plus 4 minus 2 times 2 times 3 over 2. Here we can cancel 2, and 9 plus 4 is 13, so in total we will get that a squared equals to 13 minus minus 2 times 3 is 6, so in total we got that a squared equals to 13 minus 6. 13 minus 6 is 7, so we got that a squared equals to 7. Okay, we got that a squared equals to 7. We will take a root out of this equality and we will get that a equals to the root of 7. A equals to the root of 7. So we found out the value of a. A equals to the root of 7. Okay. In the next step, we will define angle BFD as theta, angle BDF will be defined as alpha, angle EDC will be defined as gamma, and angle CED will be defined as beta. As you have already know, the sum of the angles in any triangle equals to 180 degrees, and especially in triangle BFD, the sum of its angles equals to 180 degrees. So we'll create the first equation that states that the sum of the angles in triangle BFD equals to 180 degrees. Okay, so the sum of the angles in triangle BFD is 60 plus alpha plus theta, and it equals to 180 degrees. And also in triangle DEC, the sum of its angles is 180 degrees. That will be our first equation that states that the sum of the angles in triangle DEC equals to 180 degrees. That is to say, 60 degrees plus gamma plus beta equals to 180 degrees. Okay, so we actually created two equations. The first equation states that the sum of the angles in triangle BFD equals to 180 degrees, and the second equation states that the sum of the angles in triangle DEC also equals to 180 degrees. Now we will add together equation 1 with equation number 2 and we will create equation number 3. So 60 degrees plus 60 degrees is 180 degrees, plus theta plus alpha plus gamma plus beta. 180 plus 180 is 360 degrees. So in total we got that 120 degrees plus theta plus alpha plus gamma plus beta equals to 360 degrees. We will subtract 180 degrees from this third equation and we will get that theta plus alpha plus gamma plus beta equals to 240 degrees. Okay, we subtracted 180 degrees from the third equation and we got that theta plus alpha plus gamma plus beta equals to 240 degrees. Okay, our fourth equation will be the following. Actually, around point D, we have the side BC of the equilateral triangle ABC, and we know that the sum of the angles in the upper side of a straight line or line segment equals to 180 degrees. So the sum of the angles in the upper side of side BC will be equal to 180 degrees. That is to say, alpha plus 90 degrees plus gamma will be equal to 180 degrees. So I will write it down that alpha plus 90 degrees plus gamma equals to 180 degrees. That is to say, the sum of the angles in the upper side of side BC of the equilateral triangle equals to 180 degrees, or alpha plus 90 degrees plus gamma equals to 180 degrees. Now we'll subtract 90 degrees from the fourth equation and we will get that alpha plus gamma equals to 90 degrees. Okay? So in the fourth equation we subtracted 90 degrees and we got that alpha plus gamma equals to 90 degrees. And we have in the first equation alpha plus gamma. So we can substitute alpha plus gamma in the third equation by 90 degrees because alpha plus gamma equals to 90 degrees. So we will substitute alpha plus gamma in the third equation by 90 degrees. Okay? And we'll get that theta plus 90 degrees plus beta equals to 240 degrees. So we substituted alpha plus gamma by 90 degrees in the third equation and we got that theta plus 90 degrees plus beta equals to 230 degrees. We'll subtract 90 degrees from the third equation, and we will get that theta plus beta equals to 150 degrees. Okay, we subtracted 90 degrees from the third equation, and we got that theta plus beta equals to 180 degrees. We will subtract theta from the third equation, and we will get that beta equals to 150 degrees minus theta. Okay, we got that beta equals to 150 degrees minus theta. Okay, so in the next step we will find the value of sinus theta according to the law of sines. What is the law of sines? Actually, the law of sines states that if we have triangle, any triangle, the law of sines applies to any triangle in the world. If we have triangle with sides A, this is side A of the triangle, this is side B of the triangle, and this is side C of the triangle. This angle is angle alpha, this angle is angle beta, and this angle is angle gamma. Then the following relationship exists between the sides of this triangle to its angles. According to the law of sines, A over sinus alpha equals to B over sinus beta equals to C over sinus gamma. Okay? So, according to the law of sines, A over sinus alpha equals to B over sinus beta equals to C over sinus gamma. It is true for any triangle. Okay? Now we will implement the law of sines in triangle BFD. In triangle BFD, this triangle FD over sinus 60 degrees equals to BD over sinus theta. Okay, in triangle BFD, FD over sinus 60 degrees equals to BD over sinus theta according to the law of sines. Okay? But we know that FD equals to the root of 7. So we will substitute FD by root 7. And sinus 60 degrees equals to root of 3 over 2. And BD equals to 2 units, and sinus theta is sinus theta. Okay, we'll find out the value of sinus theta by this equality. Okay, so we got that the root of 7 over root of 3 over 2 equals to 2 over sinus theta. Okay, we will do the simple arithmetic here, and we will get that 2 times root of 7 over root of 3 equals to 2 times sinus theta okay, we got that 2 times the root of 7 over root of 3 equals to 2 over sinus theta. Okay, so here we actually will find out the value of sinus theta. We will multiply this equality by root of 3, and then we will multiply it by sinus theta, and then we divide it by 2 times root 7. So we will get that sinus theta will be equal to 2 times root of 3 over 2 times root of 7. Okay, so in total we got that sinus theta equals to 2 times root 3 over 2 times root 7. We have 2 in the numerator and 2 in the denominator, so 2 can be cancelled. So in total we got that sinus theta equals to the root of 3 over root 7. Okay? Okay, sinus theta equals to the root of 3 over root of 7. Now we will find out the value of cosinus theta by the trigonometric identity that states that sinus theta squared plus cosinus theta squared equals to 1. Okay, we will find out the value of cosinus theta according to this trigonometric identity that states that sinus theta squared plus cosinus theta squared equals to 1. We will subtract sinus theta squared from this equality, and then we will take a root out of the equality, and we will get that cosinus theta equals to 1 minus sinus theta squared. Okay, first of all we subtracted sinus theta from this equality, sinus theta squared from this equality. We got that cosinus theta squared equals to 1 minus sinus theta squared. Now we will take a root out of this equality, and we will get that cosinus theta equals to the root of 1 minus sinus theta squared. Okay, we took a root out of this equation, and we got that the value of cosinus theta equals to the root of 1 minus sinus theta squared. But we know that sinus theta equals to root 3 over root 7, so sinus theta squared will be equal to 3 over 7. Okay, so sinus theta squared equals to 3 over 7. Sinus theta squared equals to 3 over 7, so we can substitute sinus theta squared by 3 over 7. We'll get that cosinus theta equals to the root of 1 minus 3 over 7. Okay, so we got that the value of cosinus theta equals to the root of 1 minus 3 over 7. 1 minus 3 over 7 is 4 over 7. So I write it down. So we got that the value of cosinus theta is the root of 4 over 7. The root of 4 is 2, so I write it down. So in total, cosinus theta equals to 2 over root of 7. So we got the value of cosinus theta, it equals to 2 over root of 7. And we have already found out that the value of sinus theta is the root of 3 over root of 7. Okay, the value of sinus theta equals to the root of 3 over root of 7. Okay, so cosinus theta equals to 2 over root 7, while sinus theta equals to the root of 3 over root of 7. Okay, as you remember, we found out that beta equals to 150 degrees minus theta. This is our further question. In our further question, we found out that the value of beta is 150 degrees minus theta. So if beta equals to 150 degrees minus theta, then sinus theta will be equal to sinus 150 degrees minus theta. Okay, so sinus beta equals to sinus 150 degrees minus theta. Okay, beta equals to 150 degrees minus theta, so sinus beta equals to sinus 150 degrees minus theta. Now we'll find out the value of sinus 150 degrees minus theta according to the trigonometric identity of sinus alpha minus beta. We have the trigonometric identity that states that the value of sinus alpha minus beta is actually equals to sinus alpha cosinus beta minus sinus beta cosinus alpha. Okay, we have this trigonometric identity that states that the value of sinus alpha minus beta is sinus alpha times cosinus beta minus sinus beta times cosinus alpha. So we can implement this trigonometric identity in order to calculate the value of sinus 150 degrees minus theta. So actually the value of sinus 150 degrees minus theta according to this trigonometric identity will be, it will be equal to sinus 180 degrees times cosinus theta minus sinus theta times cosinus of 150 degrees. Okay, so we actually implemented the trigonometric identity in our expression sinus 150 degrees minus theta when alpha equals to 150 degrees and beta equals to theta. Okay, actually the value of sinus 150 degrees is 1/2 times cosinus theta, but the value of cosinus theta, we have already found out that the value of cosinus theta is 2/√7. Okay, so here sinus of 150 degrees is 1/2 and cosinus theta equals to 2/√7. Okay, then we have also minus sinus theta. The value of sinus theta is √3/√7 times cosinus of 150 degrees equals to minus √3/2. Okay, so in total we got 1/2 times 2/√7 minus √3/7 times minus √3/2. Here minus times minus is plus, and we actually have 2 in the numerator of this expression. We have 2 in the denominator, so 2 can be cancelled, and in total, and minus times minus is plus, so in total we will get that 1/√7 plus, and root of 3 times root of 3 is 3, so in total we got that 1/√7 plus 1/√7 equals to 3/2. Here we can take out 1/√7 as a common factor. So 1/√7 is a common factor. We will take a common factor of 1/√7 on this expression, and we will get that 1/√7, in brackets we will have 1 plus 3/2. So actually sinus beta equals to, so in total we got that sinus beta equals to 1/√7, 1 plus 3/2, because we took out 1/√7 as a common factor. Okay? Here 1 plus 1/2 is 5/2, 2.5 or 5/2. So we can write here that sinus beta equals to 1/√7 times 5/2. Okay, so we got that sinus beta equals to 5/√7 times 2. Okay, so now that we found the value of sinus beta, we actually can implement the law of sines in triangle DFC. So actually, and we will find out the value of B. Okay, so in triangle DFC, this triangle, we will implement the law of sines in triangle DFC. According to the law of sines, DC over sinus beta equals to B over sinus 60 degrees. Okay, according to the law of sines, DC over sinus beta equals to B over sinus 60 degrees. As you can see from this equality, the only missing variable is B. We know all the other, we know the value of DC and we know the value of sinus beta, so we'll substitute DC. DC equals to 4 units over sinus beta equals to b over sinus 60 degrees is root 3 over 2. Okay, in total we got that we substituted DC by 4 and sinus 60 degrees is root 3 over 2. In total we got that 4 over sinus beta equals to b over root 3 over 2. We'll do this simple arithmetic. We'll get that 4 over sinus beta equals to 2b over root 3. Okay, we got that 4 over sinus beta equals to 2b over root 3, and the value of sinus beta is very simple, equals to the value of, we want to find out the value of b. We want to find out the value of b. We know that the value of sinus beta is 5 over root 7 times 2. Okay, so we will substitute sinus beta by its value, and we will get that 2b over root 3 equals to 4 over sinus beta. Sinus beta equals to 5 over root 7 times 2. Okay, we got that 2b over root 3 equals to 4 over 5 over root 7. We'll do this simple arithmetic. Two b over root 3 equals to 4 times root 7 times 2 over 5. In total, we got that 2b equals to 4 times root 7 times 2 over 5. Here we can cancel 2. We have 2 in the numerator of this side of the equation. We have 2 in the other side of the equation, so 2 is cancelled. We'll multiply this equality by root 3 and we will get the value of b. So the value of b will be equal to 4 times root of 3 times root of 7 over 5. Okay, the value of b equals to 4 times root 3 times root 7 over 5. But we know that the area of any triangle is the base of the triangle times the height to the base over 2. So the area of this triangle will be a times b over 2. The area of the green triangle equals to a times b over 2. Okay? This is the area of the green triangle, a times b over 2. And the value of a is root 7, and the value of b is root 7 times root 3 times 4 over 5. So a times b over 2 So in total we got that the area of the green triangle equals to root of 7 times root of 7 times root of 3 over 2 times root 7 times root 7 times root 3 times 4 over 2 times 5. Root 7 times root 7 is 7 and 4 over 2 is 2, so I write it down. So the area of the green triangle equals to 7 times 2 times root 3 over 5 square units. Okay, the area of the green triangle equals to 7 times 2 over root 3 over 5 square units. 7 times 2 is 14, so I write it down. So the area of this green triangle equals to 14 times root 3 over 5 square units. Okay, the area of the green triangle equals to 14 times root 3 over 5 square units, or in terms of numbers, the area of the green triangle equals to 4.85 square units. Okay, the area of the green triangle equals to 4.85 square units. Okay, the area of this triangle equals to 4.85 square units. Okay, now I will summarize the lecture. Actually, we wanted to find out the area of the green triangle. We have here an equilateral triangle, and we know that the size of BD is 2 units and the size of DC is 4 units, and AF equals to BF, and we also know that angle FD EDF, this angle is a right angle, it equals to 90 degrees, and we want to find out the area of the green triangle. And first of all, BD equals to 2 units and DC equals to 4 units, so BC equals to BD plus DC, it is 2 plus 4, so BC equals to 6 units, and we know that all the sides in an equilateral triangle are equal to each other, so AB also equals to 6 units and AC also equals to 6 units. And we also know that all the angles in an equilateral triangle equals to 60 units. Okay, and we know that AF equals to BF. So we defined AF as X, so BF will be defined also as X. So actually AF plus BF equals to AB. And AF is X and BF is X. So AF plus BF is 2X, and 2X equals to AB, and AB equals to 6 units. So actually we can write that 2x equals to 6 units, because AB equals to 2x equals to 6 units. So 2x equals to 6 units. We divided this equality by 2 and we got that the value of x is 3 units. So the value of BF is 3 units and the value of AF is also equals to 3 units. Okay, so in the next step we actually implemented the law of cosines in order to find the value of FD. We defined FD as A and ED as B, and the law of cosines states that in any triangle, if this is side A, this is side C, and this is side B, then C squared equals to A squared plus B squared minus 2 times AB cosinus theta. Okay, so we implemented the law of cosines in triangle BFO. So according to the law of cosines, A squared equals to BF squared plus BD squared minus 2 times BD times BF cosinus 60 degrees. Again, A squared equals to BF squared plus BD squared minus 2 times BF times BD times cosinus theta, according to the law of cosines. Okay, so we have all the values of all the variables here, and the only missing thing is A. So we put the data inside this equation and we got that the value of A is root 7. A equals to root 7. Okay, and then we define this angle as alpha, this angle as theta, this angle as gamma, and we define this angle as beta. And we know that the sum of the angles in any triangle is 180 degrees, and especially the sum of the angles in triangle BFD equals to 180 degrees. So we can write down that 60 plus theta plus alpha equals to 180 degrees. This is our first equation. Our second equation states that also in triangle EDC, the sum of its angles equals to 180 degrees. That is to say, beta plus 60 degrees plus gamma equals to 180 degrees. So we created two equations, and then we added together those two equations, and we also, in this way, we got our third equation, and we also created the fourth equation that states that the sum of the angles in the upper side of a straight line equals to 180 degrees. That is to say, alpha plus 90 degrees plus gamma equals to 180 degrees. Okay, alpha plus 90 degrees plus gamma equals to 180 degrees. We got that alpha plus gamma equals to 90 degrees from equation number 4. So if alpha plus gamma equals to 90 degrees, then we can substitute alpha plus gamma in equation number 3 by 90 degrees, because alpha plus gamma equals to 90 degrees. So we substituted alpha plus gamma in the third equation by 90 degrees, and we got that in total that beta equals to 150 degrees minus theta. From our third equation, we got that beta equals to 150 degrees minus theta. Okay, then we actually implemented the law of sines in order to find out the value of sinus theta. The law of sines states that in any triangle, if this is side A, this is side B, and this is side C, this is angle alpha, this is angle beta, and this is angle gamma, then A over sinus alpha equals to B over sinus beta equals to C over sinus gamma. And we implemented the law of sines in triangle BFD. In triangle BFD, we can say that FD over sinus 60 degrees equals to BD over sinus theta. Okay, in triangle BFD, we can implement this law of sines that states that FD over sinus 60 degrees equals to BD over sinus theta. Okay, but we know that FD equals to the root of 7. Sinus 60 is the root of 3 over 2. And dB equals to 2 units. And sinus theta is sinus theta. So we found out that the value of sinus theta is the root of 3 over root 7. Okay, and from sinus theta we found out the value of cosinus theta by this trigonometric identity that states that sinus theta squared plus cosinus theta squared equals to 1. We subtracted from this identity sinus theta squared, and we got that the value of cosinus theta equals to the root of 1 minus sinus theta squared. We know that sinus theta equals to the root of 3 over root 7. So sinus theta squared will be equal to 3 over 7. Okay, so we can substitute sinus theta squared from this equality by 3 over 7. Okay, we can substitute sinus theta squared in this equality by 3 over 7 because sinus theta squared equals to 3 over 7. Okay, and we substituted sinus theta squared by 3 over 7, and we got that the value of cosinus theta equals to 2 over root 7, while the value of sinus theta equals to the root of 3 over root 7. So we know the value of cosinus theta and sinus theta, and we have already found out that the value of beta equals to 150 degrees minus theta. If beta equals to 150 degrees minus theta, then sinus beta equals to sinus 150 degrees minus theta. Okay, and we found the value of sinus 150 degrees minus theta according to the second trigonometric identity that states that the value of sinus alpha minus beta equals to sinus alpha times cosinus beta minus sinus beta times cosinus alpha. Okay, so here we'll calculate the value of sinus 150 degrees minus theta according to this trigonometric identity when alpha equals to 150 degrees and theta equals to beta. Okay, so we implemented this trigonometric identity to calculate the value of sinus 150 degrees minus theta, and that equals to sinus beta. Okay, so we found out that the value of sinus beta is 5 over root 7 times 2. Okay, after we know the value of sinus beta, we can calculate the value of b, because according to the law of sines, b over sinus 60 degrees will be equal to 4 over sinus beta. Again, according to the law of sines, in triangle DFC, DC over sinus beta equals to DF equals to DE over sinus 60 degrees. So, and we know that DC equals to 4 units, sinus beta equals to 5 over root of 7 times 2, and the only missing variable is b. Okay, so we put the data inside this equality, and we found out that the value of b is actually 4 times root of 3 times root of 7 over 5 units. But we know that the area of any triangle is the base of the triangle times the height to the base over 2. Okay, so the area of the green triangle will be equal to the base of the triangle that is B times the height to the base. The height creates 90 degrees with the base. This angle is 90 degrees. So the height is A, the base is B. So A times B over 2 is the area of the green triangle. A times B over 2 is the area of the green triangle. And we know that A equals to the root of 7, and the value of B, this is the value of B, so we know the value of A and B. We put the value of A and B in this formula for the area of triangle, or for the formula for the area of the green triangle. So we put the value of A and B in this formula, and we got that the area of the green triangle equals to root 14 times root 3 over 5 square units, or in terms of numbers, the area of the green triangle equals to 4.85 square units. Again, the area of the green triangle equals to 4.85 square units. Okay, thank you very much.